9 o'clock, so I expect people will drift in maybe. While I'm talking, if anybody has any questions, just raise your hand or just speak. But speak loud enough so I can hear you. And answer what I have. If you need me to be louder also, just raise your hand. I have no idea what people can hear. Yeah, pretty good in the background. That's good enough. I can just talk like this all the time. Easier for you. Okay, so this talk is going to be about security, but more practical security in terms of the things that we actually use as developers. So before starting, what I thought, to get a sense of who's here and what you know, I want some hand raising if that's okay. So who can raise their hands? Okay, most people, we're good. It's a good start. So who is a developer, like a programmer? For the most part. All right, that's good, so most of you. What about C programmers? Okay, so just to let you know, this is a C-oriented presentation, but as I'm going to tell you later, all the things I'm talking about can be done in other languages. Everything can be done in any other language you want. So these are more about techniques. The difference between the other languages and C is that there are implementations in C now, and not in other languages. So that's the difference. So what about web applications? Who does web applications? All right, a few of you. Backend. Okay, so mostly backend people. How many front-end developers? Okay. All right. Just to give myself a sense of who everybody is. So OpenBSD? Okay. FreeBSD? Okay. I'll try to hew it a little bit toward FreeBSD. I do talk about a lot of techniques for OpenBSD primarily, but again, everything can be done in FreeBSD fairly easily. And when I say FreeBSD versus OpenBSD, all I'm talking about is pledge. That's really it. But Capsicum can be used for most, if not all, of the strategies I talk about. I personally have not implemented it for a lot of the tools I'm talking about, but it is pretty easy to work it in there because for these purposes, you'll see, very interesting. All these slides are up on the web at the addresses listed right there. So at any point in time, if you can't hear me or you get bored and you want to look ahead, you can go see them there. It works on your phone and stuff, so it's very easy to see. Let's get started. So this regards what's called BCHS. Who's heard of BCHS? A few of you. Okay. So if you want to cause trouble on like Reddit or Hacker News or whatever, just post things about writing C applications, CGI applications in C, and just watch the fun unfold. It's a great pastime. If it's raining out or something like this, and you're feeling down and you want to feel good about yourself, just do that, and you'll realize what a good person you are when you see what other people are. So I anticipate some fun if people syndicate this on those sites. So this again is about BCHS. BCHS is about BSD programs in the C programming language that use the SQLite database. And HTTPD was just to make it be BCHS and not BCS, which is harder to say. Because I can say beaches, which is the official pronunciation of BCHS. BCS doesn't mean anything, so that didn't make sense. All that we're talking about can be used on stock, OpenBSD, and again, we'll talk about FreeBSD as well. So why, in this talk or in general, do I focus on BCHS? It's kind of important that we understand the landscape here. I use OpenBSD primarily just because it's very simple to set up. I use FreeBSD sometimes, but not as often. Most of my servers are OpenBSD. It's just very easy. Everything is standard in them, and that is very important to me because I'm the kind of person who makes mistakes and messes things up very quickly. So if it's already done for me, I can't mess that up as much. Why do I use a C programming language? It's very portable. libc can be less portable, but in general, if you're writing in C, everything has a C compiler. People will talk a lot about C not being portable because the library is not that portable, whether you have stir or copy or whether stir time has different arguments, but that's not really about the language, it's about the library. So for the most part, C works everywhere. It's also very fast, which we'll talk about later. And it's fast not in terms of the language being fast, but in terms of startup time. So if you fork and you're writing something in C, it's very fast. If you fork and you're writing something in Perl, it's a little bit slower because the interpreter needs to work all over again. HTTPD is just pre-installed with OpenBSD. It's there. You don't have to do anything for it. So I like that. SQLite is kind of the stepchild here. There's no database that's very, BSD friendly except for maybe Berkeley database, and Berkeley database is questionable. And not in terms of its code quality or whatnot, but it's not something that I've used it extensively in the past. I grew up, and now I use SQLite. So they both have file-based backends. SQLite has more regular SQL. So SQL is the operative word. Berkeley databases, from what I understand, don't support SQL. It's all functional based. SQLite has become over the years larger. It used to be very simple. It also used to be in OpenBSD base, as you all might remember a few years ago. I think it was put in base originally because of Mandoc, which used SQLite for its web backend, and apropos as well. But that has since changed. Ingo has rewritten that. SQLite is now enforced. So that's why the SQLite is in there, historical reasons. But it's still great as a file-based database. And it's people trash on it and saying it's not really serious. But I have some pretty big sites, and they all run SQLite without any problems whatsoever. So PostgreSQL also would be my second choice for a bigger site. But it's more time to set up, more complicated, and we're going for simplicity here. As you can see, all of the simple to deploy, pre-installed simple. I don't say C programming language is simple just because, and OpenBSD also is simple. So what are we talking about when I say web application? How many people are familiar with the kind of the ecosystem of web applications, CGI, fast CGI? All right, well, let's do a small, tiny little crash course, as most people. What happens when we're running web applications is pretty straightforward. The moving parts we have are the client, who is the enemy, always. Client is your enemy. We have us, the good guys, in our operating system, whether it's FreeBSD, or again, in this case, for simplicity, let's just say OpenBSD. And then we have HTTPD. Too bad Ray Fletcher can't be here. He was the progenitor of HTTPD. So we have two basic tools that we use, fast CGI and CGI. There's a lot of rhetoric that fast CGI is the best. I'm going to argue against that, but not in this talk. CGI is essentially a program that is forked from HTTPD and execs, that's all. It's very straightforward. It can be anything. It can be Perl scripts, Python, whatever you have in your root. It can just be a C program, which is what we're going to focus on today. Fast CGI is a bit more complicated. The web server does not actually fork and exec anything. It sends its data to a socket. Often it's on the same host, sometimes not, it depends on how it's configured. I think that on HTTPD it's all local. And there's a manager somewhere in the distance that has started up programs that listen on that socket. It's basically all left into outside of the web server, which is great because we have a lot more control over what goes on. And that's also terrible because we have a lot more control over what's going on. I'm going to focus mostly on CGI simply because it's easier to talk about. All the techniques and the tools I'm talking about apply to fast CGI as well. It's just I don't want to have to talk about all this other stuff also, because that makes the talk twice as long. Attack surface. So when we're talking about a client, the client is always an attacker. Clients are never people you like. So none of the clients are here, they're all out there somewhere. And they're all very bad people. They're always trying to cause trouble by using our services. How dare they? So let's talk about, from the perspective of a client who wants to cause us problems, what attack surface do they have? They're sending us data. What can they manipulate in order to cause problems? And that's why we know, that's why we see that web servers have so many issues, or web applications have so many issues. Usually if we're writing something like a graphical program, we have to worry about point and click. We have to worry about maybe reading a configuration file. Or in larger systems, we have to worry about LaTeX with RDF or whatever. In a simple web application, we have to worry about all of these. So we have TCP/IP on the bottom level. We have the HTTP protocol, which is a nightmare. And we have 3 of them now to worry about. We have 1, 1.1, and the new one, 2, which is still kind of a mystery. And then we have CGI protocol, which is different from HTTP. And then we have, if you're fast CGI, then fast CGI, which is its own, protocol, which is very complicated. And then inside those, we have a notion of HTTP, and we have the parse MIME also. Now, of all of these, MIME is actually the one that is causing the most problems, I think, to people. Because generally, when we send forms over HTML, they're encoded in MIME. And MIME parsers are hard to write. So here's what we can manipulate as clients in order to cause problems in our programs. And as you can see, there's a lot to manipulate. Fortunately, there's also a lot that we have, at least in OpenBSD, to protect us from manipulation. We have the packet filter on the server itself, which is very helpful. We have all of these nice tools like KARL, ASLR, WX, all this stuff in the operating system itself to protect us. And this does a great job. This is not what this talk is about at all. And then in things like HTTPD, we have fork exec, we have privilege separation, privilege dropping, true, all this stuff. So there are a lot of protections by the time we get to our CGI script that are already available to us, and none of them are going to help us all that much, as we'll talk about. So these are the security measures that we don't have to do anything for, except for configuring PA. There's a lot out there. The other nice thing is that when we're writing CGI scripts, we don't really have to worry about all of this stuff up here. The operating system is going to take care of the lower stuff. The web server is going to take care of the raw HTTP. So all we really have to worry about is the fast CGI or CGI protocol, MIME, and then knowing enough about HTTP to process it. But we don't have to do a lot of the underlying work. But we still have to worry about a lot. So every time you write a web application, you have to worry about all of these, depending on whether it's fast CGI or CGI. That's still a lot to worry about. So in terms of our applications themselves, most web applications are simply some sort of logic in a database. Right? I mean, let's say data source to be generic, but really you're probably using a database. That's basically every single web application out there. Some of them do fancy things like starting programs and stopping programs, but they shouldn't even be doing that. It should just be a database. So our database is basically our data. The attacker doesn't really want to necessarily crash your computer. They want your data. That's the important thing. This is our vault right here, the application data. And most, if you've ever read web applications, this is the security model they use. It's nothing, it's luck. You have no idea what's going on in there. The point of this talk is to show you that you can take a little bit of control of that. So let's start with a simple web application. If you guys want me to go more into an example, then let me know. I do in the paper, but it's just kind of for metaphorical, illustrative purposes. First, we're going to use CGI instead of fast CGI, simply because it's easier to talk about. If you really want me to talk about fast CGI, I can do that. It's not going to change all that much. So just let me know during the talk, what would I do if it were fast CGI? We'll use an SQLite database. Also, it doesn't really matter if we're using Postgres. Programmatically, it makes a difference because of how we interact with the database, but not that much. There are other databases out there, MariaDB, etc. They all have a C language interface to them. So that doesn't really matter. I would, again, recommend SQLite because it's easiest to set up. But it also has its caveats, as everything does. I'll also assume, maybe something I shouldn't assume, that your application is more or less well-defined. You have known SQL queries. So you can probably go into your application and say, here are all the queries I'm going to run. Most large-size applications have these all in one place, and you index into them or whatever, so that they're easy to manage. But I will assume that that exists. I will also assume that there's a good concept of roles. And the whole, obviously, this talk is about roles. So what is a role is, what is a user of your application, of your web application? Most web applications have the concept of who is using it. Is it a regular user? In a marketplace application, are you a buyer or a seller? Are you an administrator? Are you, what kind of administrator are you? Do you administer users? Do you administer sessions? Generally web applications have a structured notion of what you're there to do. as a client. Just like any business has a concept of what people do in that business. Are you a programmer? Are you in IT? Are you a manager? Are you in finance? So roles are something that we're going to talk a lot about today. And again, illustrating, so when we talk about our simple web application, this is how it's going to look. The client, the bad guy, is out there somewhere. We're running with HTTPD, and it has all those nice protections. Red means it's protected. And then we have our program, which is somewhere in CGI bin. And the only protection it really has from starting is that it's been chrooted. Who disables the chroot? Some of you want to raise your hands. I can see Meg Larkin in the back going, I want to raise my hand, because I disable my chroots.
No, I'm biting my nails.
No, this used to be really popular. I don't know if, I mean, everybody probably has done this at some point, where you're running an application and you start it doesn't work. And then what's the immediate answer is disable the chroot. It's a very classic maneuver and very, very bad. So you should not raise your hand right now. Just feel guilty, what you should be doing. Our CGI script is going to be chrooted in this example, and it's going to use the SQLite3 interface in order to talk to the database. SQLite doesn't have any man pages, so you have to use their online C reference. I did write a tool that converts that reference into man pages, but it's not, from what I understand, in any downstream. So that's what physically things are going to look like. We have the web server, it's running, we've configured it. I'm not going to go into that. We have our program, which has also been configured to run, so it does run. We have a database. All permissions have been taken care of. Everything there is all finished. We're not going to worry about that. So what can we do to be secure? You know, let's say we have a pre-existing application as well to make things interesting. We're not starting from scratch, because if we start from scratch, we can do anything we want to. The easiest way to start is Pledge. That's, if we're on OpenBSD, or if we're on FreeBSD, Capsicum, a little bit more involved, but not that much more involved. What resources are we using is what we're going to start with. Because what we're going to do is not protect ourselves, but we're going to protect the external environment first. So we're going to disable our ability to use the system resources, which is what Pledge does. Now, chroot already has established that we can't see anything but what's in the bar www. But what else can we do? First, let's start by establishing the promises for standard I/O, because in order to talk to the web server, we need standard I/O, because we're talking over our std out and std in. The second thing, and the more problematic one, is to do our database. Now, in order to have an SQLite database, we need reading, creating of files, writing of files, locking of files, and the C file attributes. So we basically need all file information. SQLite is pretty, it has issues like this. It will randomly open files in random places. It's a little problematic like that, but let's deal with it. So the problem is, in talking to our database, we need all file access, but we don't need anything else. So if we pledge with just this information right here, we are now effectively denying any attacker the ability to open sockets, to, that's really what they would do, start other programs. So now all they can do is crash our file system. Of course, the problem is that in that file system is where our most important stuff is. So now we've limited them to damaging the thing that we don't want them to damage the most. So in terms of whether this actually buys you any protection, from my perspective as somebody who has a lot of web applications, I don't care if somebody trashes my operating system because I can just redeploy it. What I do care about is somebody can trash my database, because that is going to cause me money. Who has used Pledge, by the way? I strongly recommend it. It's a really good exercise to secure in your programs. It's really easy. It's just one command. And the nice thing about Pledge is that you can put it in there, run your program, have it crash, and see which pledge you're missing, and then keep on doing that until you've got all of them. So it's actually pretty easy to use. I strongly recommend it. Who's used Capsicum? It's a little more involved, but not that much more. You have to set things up. Who's used Seccomp? I'm sorry. I'm really sorry. I understand. I've used it too. I would not wish that upon anybody. So that's good to know. Anyway, use Pledge. It's great. It's very easy. You don't need to do much. So what we have right now is we have our application. It's pledged. It can only trash what's most important to us. Have we really gotten any security out of that? I would wager not. So how are we going to start to actually look within our program and say, our application data is the most important thing to us. How can we protect that part of it? And to start with, let's consider where the danger is coming from. Remember a few slides back, I was talking about the attack surface. And a big part of the attack surface was in parsing data that comes from the client, the adversary, to us. That's where we're going to have problems. Who's written parsers for anything at all? Yeah, parsers in C. Who's written a parser in C? Yeah, that's dangerous. That's like really dangerous territory. According to Reddit, you guys are bad people, because you should never do that. Just, that's, you go on Reddit and look at C anything, you'll get people saying you're bad. So, of course, it's a natural language if we're doing nothing already. So what can we do about that? How can we protect ourselves from that attack surface? The first thing we can do is use KCGI. Disclaimer, I wrote it, but what KCGI lets us do is take all the parsing of the HTTP stuff, or the CGI stuff, or the fast CGI stuff, or the MIME stuff, puts it all into a library, and it also puts that into a child process that's been pledged. And it only talks that process over sockets. So if there's a problem in that, you're not going to damage your system. It also effectively takes that, because it's pledged, and separates it from your application data. So if there's something wrong with the parser of all of that stuff, MIME 1.0, really, you can have anything parsed in there whatsoever, then you're not going to cause a problem to your application data. So again, if we're looking at red as being protected and white as being unprotected, our CGI script is out here in no man's land. Our application data as well. But now the client, the bad guy, is talking to something in the red box. And that's good for us. So that we don't have to worry about that whole level of complexity. If you're doing your own parsing of HTTP, you have a lot of other problems though. So I just assume you have something doing it for you. So anyway, who's used KCGI? Good, okay. Well, you have something to learn. It's very handy. So there's something else we can do as well. So now let's talk about the really meaty part, which is our application data also. As I've talked about before, SQLite, because it's an in-process database, is going to be in a file, and then we're going to map that into our program. So if we have problems in our program, we have problems in our SQLite database. One of the things that I did maybe a year or two ago was write a connection manager for SQLite, where it will manipulate the database also in a child process that has been pledged appropriately, and then talk with us over sockets. So in this way, we can take the entire database access and put it in a child process. And as such, if we have problems in our program, we can drop to pledge just .io, because now we're talking to KCGI over sockets, we're talking to KSQL over sockets. We don't need to do anything else. We don't need to touch our file system, we don't need to touch anything. So we can actually drop, as we'll show this later, into a .io pledge. Now, our application, if it has problems in its logic, cannot touch the database directly anymore, which is a big win. So by using KSQL and KCGI, you both protect your database, and you protect yourself, I guess, from parsing errors. So if we look at the state of the state right now, all we really have to worry about is the data that we're getting from our client. So we can still mess that up, of course. But we've basically taken out most of the attack surface here by putting it and shoving it into child processes that are secure. So of course, along the way, those can have errors, they're just going to crash. But we're going to be protected from them. And that's the most important thing. So now, all we need to have is this .io pledge, which is effectively the most minimal one out there. And this is great, because now we have all this red stuff right here. So everything is now put in its own little box, separated from us, and we don't have to touch anything. So our CGI program, which is accepting all this malicious content, bad MIME forms, bad JPEGs. You guys remember all the problems with TIFF images and PNG parsing earlier a few years ago. We have to do that in our CGI script a lot of the time. If any one of those were to be malformatted or were to have adversarial attack vectors, then we would be compromised. But now, our application data is safe. So that is the most important thing. Now, if there's a really clever bug, of course, it can still try to interact over the sockets. Now, the amount of work for that is pretty considerable, but let's pretend that our client is a really powerful adversary who really wants our data, and it's not going to use the wrench, which is what I would use. It's just going to try to go into our application service. So let's talk next about how to handle that part. So again, what is the state of the state? In terms of the attack surface, we are now limited to just the logic of the application. And our data, our database is now separated from us. So if we crash, we can't wipe out our file system. That is a big relief. I don't know about you, but when my web application is running, and I know it can't touch my database, I feel much better. One note, if you were using PostgreSQL, a lot of the times the Postgres database is on a different server. You're communicating with sockets anyway. So this kind of, the KSQL part is largely not necessary for what's it called, libpq, I think. I don't know much about libpq and how it is written and how well it is written. But what it does do is it still gives you that ability to pledge to the IO, I think, because all the interaction is over sockets, either the localhost or totalmass, which is great. SQLite didn't have that, so I had to write it myself. But MariaDB, I think, also has a C interface that also can use sockets. I don't know how much of a local file system it needs, but it's something that, in theory, could at least be tightened down in the same way. And our goal, of course, is pledge.io. That's the goal. Now, we've been talking a lot about the client as being the most malicious person in this entire scenario, but that's not really true. Because if you think about it, who is actually the most destructive force within your program? Does anybody know? Who's the most destructive person out there?
Yourself.
Yeah, exactly. So I don't know about you guys, but I'm actually really quite bad at my job sometimes. You know, at the times it really matters. I'm really bad at that typo. You know, you forget one thing. You have a 1 instead of a 0. You have a off by 1. You know, you have the wrong pointer or something like this. You run free and then you access it. This just happens as part of writing things. If it's just you out there, you are the most dangerous person to your own program. Your database is not going to suffer because of some guy out there. It's going to suffer because of you. So a lot of these measures, I'm saying it nicely, and like the client is out there somewhere trying to cause you problems. But really what all this is going to do now is protect you from yourself. And that is really important because you are the one interacting the most with that database. You wrote all that code. So do you really trust yourself to do the right thing all the time? Now, for a small web application that's serving cat pictures, well, wait, okay. I was going to compare like gold to cat pictures, but really what we look at most is probably the cat pictures. So let's take something else like, you know, our banking information. That's not that important compared to cat pictures. So that's okay. That's just, we can handle that. But if our server is serving cat pictures and you stop serving them because you screw up, you'll have a lot of angry people. You don't want to do that. So the question is, how can we protect ourselves from ourselves? Now, Pledge does that in a physical way. So we screw up and try to do an fopen of our database and just write garbage into it, or we do a remove RF from the root or something like that. We've now protected ourselves. But really, how often does that happen? I think that's pretty uncommon to just trash files. The bigger problems are logic bugs. And that is where roles come into play quite often. So let's get started with that. Whoop, picture is too big. So before I start with role-based stuff, who has worked with role-based with RBAC? Okay, that's actually quite a lot. What about DAC or Mac? So who's used like FreeBSD, Mentor, access controls? Okay, a little bit. So you're familiar with the principles. I'm gonna just completely disregard the scientific literature and actually jump into it programmatically. So what do roles do? Roles are a way of saying who is using a service. That's our principal. You know, any one of you, all of you, you're all principals individually. But we all have different roles. Well, I mean, I'm the speaker. That's my role. You're the audience. That's your role. And then we have people filming, that's their role. And then we have sound, which is the same role, I think, right now as the person filming. And we probably have some organizers around here as well. So in just this setup here, we have about 5 roles. One of those roles, the person, the technician, actually has 2 possible roles. So it's the same person with 2 roles. Now, if we look at it in terms of a bank, I think that's a little bit easier. Because really, if we're going to do a web application, it's kind of like a bank. You have your clients arrive, they come up, and you all know what a bank looks like. You have a big wall, and then you have the clerks on one side, and then the clients on the other side. You're separated by a grate of some sort. You feel really badly and guilty. That's how I always feel when I'm at a bank. So you have the people who know, and then there's you begging for money on the other side. So we're the clients out here. And then the clerks are disbursing money or handling requests or something like this on the inside. What are our roles? We are clients. What are the clerks' roles? They are clerks. But that doesn't end right there. There are managers even further back in the offices that we never have access to. And the clerks are going to answer to the personnel manager. Now the clerk deals with the vault to give us our money. Let's pretend they're still working with paper money. It's 2018, we don't really do that anymore, but some people do. So the vault has the actual money. Clerks are going to go get the money. They're going to go bring it out. The clients never directly access the vault. The personnel manager never accesses the vault, but the finance manager might access the vault. So if we were to write a web application that goes or emulates a bank called, iBank, just give it a name, it's going to look something like this. We have the concept of clients, clerks, managers, and then we have our resources. In this particular case, we just have one resource, and that's the vault itself. So if we were to take this picture right here, and this concept, and simplify it a little bit, we would have something like this. We have managers, and you can either be a finance manager or a personnel manager. We have clients. We have a teller, which is a clerk, and then we have the vault. What I'm using is I'm showing arrows between the roles right now to see what the interplay is. The clerk never talks to the finance manager. Why would they? The finance manager never talks to the teller. The finance manager does talk to the personnel, finance manager never talks to the personnel manager, but the personnel manager manages the finance manager because they're personnel. Clients never talk to the managers, but they talk to the clerk. And then the clerk talks to the vaults. Finance manager talks to the vault. So it's pretty complicated already. But if we have thousands and thousands of clients, if we have hundreds of clerks, if we have dozens of managers, this kind of analysis using roles simplifies everything. It makes it really easy to reckon about who's using a web application and how.
There's a role missing, like obviously the back page is like trouble, but also like there's someone coming in who's not yet in time. So accounts
Yes. So we actually have the concept of you have non-authenticated users or their own role themselves. So the concept of transition between roles is a really important one. And in fact, we're going to talk a lot about that when I talk about the implementation, is how do you transition? You enter a bank in the same way that you start a web application. When you start a web application, who are you? You're nobody. You only become somebody when you reach into the database and we access your session ID and we say, you're logged in, or you have no session, so you're not. We'll talk about all that. But that's actually one of the most difficult parts. Bonnie and Clyde, I don't know if you guys have seen the movie. Strongly recommend it. But this is our second worst client. The first worst client, of course, is us. So we just talked very briefly about the concept of when you first start your web application, you don't really have a role, and then you can get it from the database. But in practice, it's actually even more complicated than that. Not much more complicated, it's a little bit more complicated. So when we start our web application, it's just spawned by HTTP. It has no knowledge of who we are or what we're doing. At that point, we have to read our session identifier, usually, if we've already logged in. Or if we're logging in, we grab the user record with our credentials. And now we know who we are. We've maybe grabbed it from an administrator table or a user table, And we know we're a client, but it gets complicated because managers in this particular case can be one of two things. We can either be a personnel manager or a finance manager. Now, one thing that I want to note, just to make things complicated, is that a manager can be one or more people. Now, in this room right now, the technician is actually two roles. They're doing sound and they're doing video. So they could also be separated out into two separate roles, two separate individuals. But the fact is that that role can be one or more things. So when we start the application, we need to figure out which one we're going to bind ourselves to. Are we going to be the role of a personnel manager or one managing finance? And to do that, we combine which page we're trying to access. As an example, there are many ways of doing this, but this is just to make things hard on us right now. So let's say we are going to access a page that is designed for managing personnel. You know, add a user, add a client, something like this, add an employee. Now at that point, if we are also, once we grab our information, if we are a manager who has that capability, we can enter that role. Otherwise, we can just say, no, there's an error. So we need both the page information as well as our user information in order to establish what our role is. Remember, a role is an abstract type. It's not, doesn't really have implementation meaning. It's something that we're going to assign. So if we have a manager with personnel rights who's going to access a page for managing personnel, then we give them the personnel role. If they were to be accessing a finance page, we would give them the finance role. A simpler way, if we're a clerk, we're always a clerk. There are no different types of being a clerk. So you're just a clerk. Same with the clients. If you were to be a clerk who's trying to access the client home, we can error out very early and return a 404 or something like this. So by the time this routine, we take the page request and the user rights, we assign a role or an error. If we have a simple system where every role just has one possibility, like you're just a manager, you don't have a manager for different types, then you can error out. By the time we run this kind of routine, which will be at the very beginning of our web application, then we know exactly who we are. So this is easy. All we need to know is our page that we're requesting. If you're using KCGI, that's just an enum. If you are, for your user rights, you're probably going to touch the database, grab your session, and say, who am I? And then you put them together, and that's done. So all of your main processing can be after you've assigned your role. Questions, by the way? That's kind of a lot to handle. But do you understand what I'm saying here? That when you start your web application, you as a client have a principal identity. You know, you're a user foo or user bar. You also have a role associated with you. And the role is defined as your role within the application's logic. And we can assign that role based upon who you are and what you're trying to do. And the only reason I say who you are and what you're trying to do is that I'm trying to make things complicated. But in some instances, you don't even need that. You can just say, who are you? Here's your role. So, you know, now we've talked about the landscape and what we're trying to do. Next is, how can we do that? Now, in KSQL, there's actually the full concept of roles, where when you start a KSQL instance, when you open a connection to the database, you give it all of the statements that you're going to run. And we said earlier that our statements are well-defined, so we can do that. And you also give it all the roles that you have defined, all of them. And you also give it a mapping of roles to statements. So you can say exactly which statements can be run by which roles. Now, I should note that SQL 99, I think, the standard, has a very basic concept of role-based access control in it. And I talk a lot about this in my paper, where some databases, PostgreSQL and MariaDB inclusive, do have a capability for role processing inside of the database itself, which is usable but not particularly portable between systems. But it is there. I don't know how well it's done. I don't know how well, well, actually, in the paper I talk about how well it's done. Well, let's ignore it for now and pretend it doesn't exist. So there are alternatives to this. Like I said, none of this needs to use C. This can be done using different systems as well. But the important thing is to think in terms of roles. KSQL, as I mentioned, has this. What it also has is how you transition between roles, which was brought up earlier. If you start a program and you don't have a role, and then you enter one, how does that work? Who is allowed to go into which role is also something that is identified. That's called transition between roles. For example, in general, you shouldn't transition between roles. Well, what if you start as a manager for finance and you want to drop those specific capabilities for finance and just become a manager? Now, as a manager for finance, you inherit all of the operations of a manager. When you drop that finance part, you can no longer touch the ball. So this is useful. Pledge is the same thing. You start with a big pledge and saying, I want files, I want processes, I want whatever. As your program runs, you shed those privileges over time. You can do the same with allback. What also it knows about is meta roles like none, where if you transition into the none role, you can't do anything at all. So look at SQL, KSQL if you want to know more about that. But suffice to say, there is strong support for this. How does it look? So this is a very simple case. And it's not that simple looking, but it is a simple case. Where we have, I will explain it. We have two SQL statements that I've shoved into an array right here. We want to insert into a test table these fields right here. And we want to select fields from the test table, just as an example. We are going to identify 4 roles. I'm not going to go into the API itself. There are many ways to improve this, but it would just be simplifying this. At the end of the day, it's going to be like this no matter what, because you need these matrices. So we're going to have 4 roles. We can call them whatever we want. It doesn't really matter. They're just identifiers. And we differentiate the roles by saying what they have access to. So each one of the roles is going to say, which statements can I run? And then we need to establish what is the transition between roles. Can everybody see the little red dot? No? Okay, yes. I'll point with my finger, it's a little easier. I'll actually point with this. So up here we have which statements we can run in our roles. So in role 0, I can run both statements. In role 3, I can run neither of those statements. And now I talk about transition between roles. So if I am in role 3, I can transition to every other role. If I'm in role 0, I cannot transition to anybody. So what does this mean? If we were to start a program, we probably want to start it with the ability to transition into all roles. We call that the default role. So, for example, you start up, you don't know whether you're going to be a client role or anything. So you say, I can transition into all roles. Now, in terms of the to no one, that could be a none role, where you can go into nobody role. The other ones are able to transition upward. So from role 2 to role 1. So we can transition upward. And this is just a way of showing a hierarchical role. It's just using a matrix for it. Again, the API in this can be made any way you want it. But at the end of the day, you're going to have 2 matrices. One of them is going to be showing which roles can access which statements. And the other one is going to show which roles can transition into which other roles. So no matter what, that's what it's going to come down to. This is showing you as it actually is in real life without a nice API doing it for us. This is real code from KSQL, so you can use this. I'm going to suggest in the next few slides a better way to do this that's much, much, much easier. And then how do we actually run this? We configure some defaults for KSQL. We give it our statements, meaning the statements that I just showed you. We give it the roles. We say how many roles we have, and we say what's the default role when we start operation. We allocate the KSQL instance in child mode, meaning starting as a sub-process that's pledged. We actually pledge ourselves at that point with std.io, and then we open our database and get going. So after this pledge right here, what happens in the database is totally shielded with us. All we're going to do is talk to it over that socket, and we're going to talk to it with the concept of a role. When we run KSQL open, we at that point are associated with a role, this default role, as I mentioned right there. Now this is nice. And this is nice because, first, if we combine this with KCGI, we have the std.io pledge and nothing more, which is great. The second thing is that so what is a usual use case here? KSQL role is the function that defines how I transition between roles. I start up in the default role, and then I see, okay, I'm a manager, so now I'm going to enter the manager role. So in this case, I'm going to do that. So KSQL has a concept of a role manager and a data manager. The role manager is going to say, which roles can you transition into? And the data manager is actually going to do the SQLite queries to get stuff out for you. You still have to write your own SQL. It does not do that. So we start out, we say which role we're going to enter. The role manager is going to take care of that. Then we're going to allocate a statement, an SQL statement. If we are allowed to get that statement because of our role, then it's okay. If we try one that is not allowed, we're going to abort immediately. So this is actually something I'm talking about with a few people now. Should I just abort? And I think that we should. Just like when you violate a pledge, it's over. And I think that we're going to take that same approach. So it just completely aborts. Now, if you try to run SQLite open raw on the database itself, Pledge is going to make sure you fail. So one way or another, if you do the wrong thing, everything's going to be killed immediately, your whole program. And that's pretty much how it should be. Yes?
What does that mean in a multi-user situation where one client out of many does something inappropriate and takes down certain resources?
Just the CGI that you're using will fail at that point.
Dedicated pledges.
Yeah. So that's the way CGI. Now, if we were fast CGI, then that fast CGI instance would exit, and it would be up to your fast CGI manager to respawn one for you. So it's pretty normal when things like that happen. So what you can do is try to warn about things in advance as much as you can. For example, in talking about changing roles, in your web application, you probably want nice warnings and errors if you try to access a resource where you don't have permission to before the abort kicks in. So before you actually run that resource. But what we want to handle is the case where your program is actually being compromised itself, and the person can play with that information and disable the warning. So they can disable that warning in their application here, but they can't change it in KSQL because it's a separate process. So you can mess with your current role in your own process space, but you can't mess with it in another process space. So that means that no matter what, you're going to fail. And that's what we want. So here's a full example with KCGI as well. It's the same exact thing, but with pausing the HTTP request at the very beginning. So still, we have the magic of pledging std.io. And that's really what we want very much. That is the guarantee that allows us to say, when we're going to audit our roles, which I'll show you a little bit later, that audit is guaranteed. So as you saw, having a huge list of matrices with ones and zeros in it is effectively the worst way to do anything. Because that is where I would mess up. 100%. And in fact, I think writing that snippet, I messed up several times as well. So if we have a big matrix that says which role is allowed to access which other role, it's like guaranteed that that is going to be the thing or you shoot yourself in the foot. So in order to make it easier, there's another program also that I wrote that interfaces with both KCGI and more importantly KSQL. It effectively lets you model your entire database, including the roles in it as well. It's called KWebApp. KWebApp is a program that, I know that there are similar tools, data modelers in other languages and other frameworks, mostly Java, that allow you to actually make a picture of your database, and then it creates the Java objects that describe that. Does anybody use any of these? Now, if you're going to write your database interface, are you writing your SQL? You're actually writing raw SQL. Who uses a tool to write the SQL for them? Any tools? Well, this does that for you. So it actually writes, it writes the SQL for you actually. It also allows you to define a configuration file, what your structures are, your tables, what they look like, and it outputs a C interface to them. So it basically does all that we just did, but automatically for you, including the roles. And actually that is, if you have a well-sized application, that table is huge. So there's one application I have that has I think it has a dozen roles. And actually, they're all administrators. Because you have an administrator who can administer other administrators, the administrator who can administrate clients, sessions, SMTP information, stuff like that. So each one of them has its own role. And in the end, that small, what here is just a few. So here is just a few things. It has hundreds and hundreds and hundreds of these at the end of the day. So it takes care of all that for you. Because I think it has maybe 200 SQL statements, something like that, 100 to 200 SQL statements. We have a dozen roles. These things are big at that point in time. So I would never be able to do that on my own. The tool manages all that for me. So I'm going to briefly show you how you can use that. All of this, as I mentioned, is all online. It's all ISC licensed. So you can use it. KWeb app effectively takes a configuration file, runs it through a program, outputs C code for you, and that C code is linked into your CGI program. It's just a file. You compile it along with your program. It's like Yak, kind of, but instead of taking the completely unreadable, ridiculous Yak format, it takes it nicely tabs with comments and everything. It's easy if you're brilliant, he said. That's what he said. And it takes a little configuration file, spits out the KSQL stuff. That does all the interaction with the SQLite. So you don't have to do any of that. It doesn't have a graphical interface because I just wouldn't use that. And it also does all sorts of other stuff. Let's not care about that right now. But how would roles look? So basically, on the left-hand side here, we would have a configuration that describes 3 database tables. A session, a user, which I'm calling a session because it's wrong, and a company. And we are going to define fields, which are columns, or if the C interface is going to emit all this as structs. So here we have a user, which is a nested structure. So every session has a user attached to it. And it's going to use a foreign key reference on the user UID. It's going to have a token because you know how sessions work, there's a random token. Modification time ID. I'm going to be allowed to iterate over it. So the iterate is going to produce C code. We don't really care about that. What's most important here are the roles. So here I'm going to define no roles. Usually you have all your roles in here, but if we just use the role statement, then we get the concept of a default role, a none role, and a role for everything. So here, I say that the default role, which means the one that I start with, is going to be able to insert and delete sessions. This is going to produce a C API, which is going to have structures. I've kind of cut them all out of it, as well as functions. So db session insert is going to accept user ID token modification time, and it's going to insert it. It will only operate if we're in the default role. KSQL will abort if you enter the none role. So this is a very easy way of managing all that for us. Now, here's a great part that I use the most. It's auditing. So who audits their web application code? Who audits their databases? Like, nobody. Because why? It's hard. It's ridiculously hard. If you are unfortunate enough to be in a situation where you need to write code that an auditor is reading, like if certain regulations apply to you, being able to audit your database and your code and access, so if you have roles, it could be considered an access role. I'm not going to say the name of the regulation because I'm probably not supposed to, but there are regulations where this is very important. And the nice thing about KWeb app is that it lets you say what each role can do exactly. And it will produce nice tables using HTML and JavaScript that allow you to look at that. And here's an example that I've embedded in the page. This is actually a reel. It's been produced by KWeb app. I just spliced it out and put it directly into this page. So my user role, this solid documentation, is allowed to do 1 deletion, 1 insertion, 1 search, and 2 updates. I can update email, I can update my password hash, I can look at what these do. User updating unique email. I can see for each one of my tables what that user can actually access. So in the user table, we have the data fields we saw earlier, the company ID, the actual nested company structure. Some of them are not exported. I'm not showing you the full example before because it would take too long, but we can control what's exported and what we actually get out of the database. And I can show you how I access everything. So this is very handy. Again, if you have to work with regulations, and some guy with a suit is going to come in and say, I need to audit who has access rights to your data, you can pull this up and say, every user has exactly this access to my data, and nothing else. Yes? Oh, we have about 5 minutes left, but that's also good because
What? You're 10 minutes over already.
it's done. Yeah. I've done this a few times, Mr. Dexter. Yeah. No, not yet. So that was just for the timing. Okay. So that's it. What we've gone over basically in full is first establishing that roles are useful. Well, first we establish what a web application is, which I just assume that people don't know. Second, we talked about doing it in C, and we just kind of identified that the reason that this is in C is because it's in C. It doesn't need to be. It can be in any language you want that has access to Pledge. You need Pledge to establish the guarantee. And that is really a pivotal part, working on the hard work of others. So without Pledge, this is all useless. Nothing is going to get you anything. Maybe if you could do very clever chaluding, you could affect a similar situation. But without the concept of being able to pledge things, you have nothing. So using Pledge, we were able to not only secure our application, our external environment from the application, we're also able to separate out the data of our application from the application, and we're also able to look at individual roles running within our application and protect them from other parts of the database. And all that builds off of Pledge, basically. Or Capsicum if you want to use that. That's it. I'd like to thank Sato-san and the HBSD organizers and some company to build these things. Any questions? I explained everything so well. Nobody has any questions, except for one. Yes?
What's the most interesting driving is the design of the organization. If you do the sequence is SLAs.
With what?
SLAs.
Yeah, you could use, so the tool that you use to do that compartmentalization can be anything. Again, the reason I use Pledge is that it's really easy. Yeah, but I mean, for example, KCGI does work with not SE Linux, but with SecComp as well as with Capsicum. So that's out of the box with that. KSQL just has Pledge support, but could very, very easily be extended in the same way. Once you get around to the nitty-gritty of actually doing sandboxing, that's where it makes a huge difference. And for something like SQLite that just magically opens things sometimes and we don't really know what it's doing, it can be a real nightmare. But yes, we can use any language. We can even use Perl. But this happens to be C. And that's that. Any other questions? You don't have to, because you're getting started now.
You realize your slot was 45 minutes, not an hour, right?
No, I did not. I thought it was an hour. Okay, we're done.